Hi everyone, let's solve today's daily challenge, that is missing number. So in this question we are given the array nums containing n distinct numbers in the range 0 to n, and we need to return the only number in the range that is missing from the array. So the question might seem very simple to do, but let us explore all the different options by which we can solve this question. Okay, so let's first get into to understand what the question is. So in this question we are given numbers in the range 0 to n, okay, and inside of your array only n minus 1 numbers are given, and these are distinct, okay, they're not repeated. So these are distinct n minus 1 numbers that are given to you inside of an array, that is nums, right? So here in the nums array we have 3, 0 and 1, right? So all the numbers are in the range 0 to n, and here we can clearly see that it is 2 that is missing from this array, right? Because the numbers were supposed to be 0, 1, 2 and 3, right? These are in the range 0 to 3, 0 and 3 both inclusive. And in nums array we are only given n minus 1 distinct numbers, and we have to find what is that missing number that is not present inside of nums, right? So I hope the question is very clear. Now let us try to understand how we can solve it. So the first approach is very clear, and the first approach is to simply sort, right? If we sort nums, we can see we'll get 0, 1 and 3. Now what we will do, we will simply check. See, your array should originally be like, it should have been like this, right? And it is now this. So if, let's say, if the array was like this, so this is 0th index, first index, second index, third index, so all the numbers must have been matching their index, correct? They must have been matching their index. So here you can see it is 0, 1 and 2. So here at this particular index they are not matching, which means that this particular index value, right, that we can return. The reason is here it is the number which is present in the array, right? But we have to return the number which is missing. So obviously because these two mismatch, that means whatever is the index, right, this number is not inside the array. Otherwise in the sorted order we would have gotten it. So here we would have to return 2, right? Let's say in a case when all these numbers match, let's say it was 3 that was missing, that is we would have gotten this. So now everything would be matching. So that means we have to simply return the last element, that is n here, okay? So this is the very first approach. So all right, so for this approach, the time complexity would be, for sorting it would be n log n, right? And for checking this mismatching index, it would be n. So overall n log n, but this is the time complexity. Now let us come to our second approach, right? So this is using, let me write it, sorting. First approach, right? Let us look at the second approach. In the second approach, what we can do is we can try to do a binary search rather than, see, what we were trying here after sorting, right? After sorting, what we did, we tried to simply iterate in this array and find that index which is not matching. The same we can do inside of a binary search, but we would have to sort because binary search is always applied in sorted arrays, right? So in that case our time complexity would become n log n plus log n. So how we would be doing our binary search, instead of this linear search to find this mismatching index, we would find a mid element and we would check if this mid element, right? So we'll simply check if nums of mid matches this mid index. That would be our condition in binary search. If it does not, then we have to return this mid index only. So that means this mid index, right, this particular value does not exist in the array and it is the missing number. So this is the second approach using binary search. Now let us, so see, the time complexity here is also n log n, here also n log n. Can we reduce it? So definitely. So using what approach? What now we can do is, let's discuss our third approach to solve this problem, that is using a map. Using map, right? That is hashing. Now using hashing, how can we solve this question? So simply what we would do is, see, we have two things here, right? This is what the array should be like, right? We should have all the numbers from 0 to n. But there would be a number that would be missing from here, right? So it would be like this. So this is the array that is given to you. Now, what we would do in hashing is we would store these are the index, right? So inside of a hash map, what we'll store the index, okay, and as well as the nums of I, whatever value is present at that index. Now, why are we storing this, right? Here we already saw what are we trying to match. We're trying to match the index with the numbers, right? 0, 1, 2, 3, 0, 1, 2, 3. So it's kind of, they must be like appearing in pairs, right? So if they must be occurring in pairs, then what I would do is I would hash the index as well as nums of I. So there would be one index value, right? That would have any number, right? That is going to have frequencies 1 only. All other numbers will be having frequency 2, because we are also putting the index as well as whatever is present at that index. Let's see here. What are we going to do? We're going to hash index as well as the number 0, 1, 2. So for 0, here and here 0 is present. So inside of our map, 0 will contain 2 frequency, right? For 1, right? 1 would contain 1 is here and here. So it would be having 2 frequency. For 2, we would be having only 1 frequency. And for 3, uh, this would give us a frequency. And as I said, we have to also include last index here, right? Because in some cases we might be having this as the missing number, right? So we have to also, after we loop through nums, we will simply put n inside of the hash map. So for 3 also we'll get 2. So now you can see clearly here for this 2 number, right? It is having frequency 1. That means as soon as I get a number with frequency 1 inside of my map, I'll simply return it. So which is in this case 2, right? So I hope the this approach is clear, right? What we are trying to do. We are trying to hash all the values. What values? We are trying to hash the index as well as the numbers present inside the nums array, and we are finding that number which has the frequency 1, because we already saw that it should be like this, right? So everything must be appearing in pairs, but there would be that one number whose index is definitely present, but that number is not present, and that number's frequency would be 1 in that case. So we'll simply return that particular number. So this is the third approach. Let us see the time space complexity. So time complexity here would be big O of n. Why? Because we are iterating inside of nums to create the hash map first. Then we are iterating in the hash map, right? We are iterating in the hash map trying to find a number with the frequency 1. So time complexity is big O of n plus n, which is big O of n only. Space complexity would also be big O of n here. Okay. All right. This was the third approach. Now, so we have definitely reduced the time complexity. As we know, we would have to like iterate a nums array anyhow, but can we reduce the space complexity? Let us see. So let us discuss. Let's come to our fourth approach. In the fourth approach, we are going to use bit manipulation. Okay. All right. Now, using bit manipulation, how can we solve this question, right? If you're not clear what bit manipulation is, you can check it out on like search by searching. But it basically means you're trying to do operations by opening the number up into bits, that is in its binary format, and you're trying to perform or, and, XOR, these operations. So there is this XOR operator. There is this XOR operator in bits manipulation. So what is the property of this XOR operator is, if you like take pair of a number, right? Let's say if you do x XOR x, you will always get 0. Okay. So we can use this XOR property to solve this question, because here again, look at this. We are trying to look at pairs, correct? So what we'll do is we'll calculate again what we will consider the array, consider its index, and keep calculating the XOR. So as you know, you'll go all along the array, right? Calculate the XOR here. So you'll say calculate nums of I XOR I, and please store it somewhere, and also XOR it with that. So let's say it's ans, right? So inside of this ans, we'll be storing nums of I XOR I, and we'll XOR it with ans. So in the end, I know, because by using this property, right, all the pairs will get cancelled out, and we would be left with um one number whose pair is missing, right? And that number will be our missing number, right? Because it's very clear here. See what I'm trying to say. Calculate the XOR of these two, store it in ans, right? Then when you calculate the XOR of these two, right, then in the ans, because 0 0 they'll get cancelled out, and 3 XOR 1 will be stored. Then store the XOR of 1 and 2. So you can see that this would get cancelled out, and 3 XOR 2 would be left. And as I said, you have to also XOR it with the last index, because you cannot access it inside of the array. So you'll do XOR with n, that is 3 in this case. So again 3 XOR 3, right? They will get cancelled out, and answer you will be left with 2. So here 2 is your answer, right? So this is how this XOR is going to work. Now for this XOR operation, the time complexity is only big O of n. Why? Because you're going to do only one iteration inside the array, and space complexity is big O of 1. So here you can see that we have reduced the space complexity and time complexity also by one loop, because we are not using in two loops here, right? So that's our fourth approach. And obviously, you cannot go further below this time complexity, but there is another approach that you can use, that is using sum. So that is pretty clear. Like, I hope you know the sum of n numbers. So if you want to like add sum of n, right, that is 1 plus 2 plus 3 plus up to n, right? So the formula for this is n into n plus 1 by 2. Okay, so that means you know the sum to this, right? And what you can do is you can take the array and sum it up, right? After you take the sum of this, right, ideally it should be sum of n numbers, right? But it is not, because one number is missing. So you'll get some sum here. So in this case it would be 4, but your sum should have been 0 1 2 and 3. So if you add these four numbers, what you are getting, ideally this is the sum, right? And because 0, we do not really care, 0 plus n plus 1, it would still be the same, that is n into n plus 1 by 2. So n is what, 3. So 3 into 4 divided by 2, so it's going to be 3 to the 6, right? So you calculate the sum here, you calculate the sum of the array, and then you simply subtract from the ideal what the ideal sum should be. Ideal sum is n into n plus 1 by 2. You simply subtract what you're getting in this, right, from the array. So you'll get 2. Again, 2 is our answer, and that is how we can solve it using this sum property as well. So the time complexity here is going to be big O of n, because you have to calculate the sum of the array. So you have to iterate in the array. And the space complexity will be big O of 1, because we are not using any extra space. So I hope all these approaches are clear to you. So we discussed 5 approaches here. So the first approach was using sorting, which is very obvious. Second approach was, instead of iterating for the second loop, right, in big O of n, you try to reduce it by using binary search. That is, you reduced it to log n. So that was the second approach. Third approach was to use hashing, right? Store these values inside the map, and because you know that you have index and you have the array elements, there would be one index for which you will not be having anything, right, inside the array. That means that index would be having only one frequency, and that you have to return after iterating in the map. Then we reduced the time complexity and space complexity further, and we used bits manipulation. In bit manipulation, we use the XOR operation, and we try to solve the question using XOR operation by using this property of XOR, right? There is another property of XOR, that is x XOR 0 will be x only. So ans initially would be 0, and you can keep calculating further, right? And then the fifth approach was to take the sum and simply yeah, so the sum ideally should be n into n plus 1 by 2, and you'll take the sum from the array. So you know ideal sum is this, the current sum is this, and you can simply subtract the sum from the ideal sum, and you'll get your answer. that is the missing number. So I hope all the approaches are clear. So here let us choose to do this XOR operator, right? Because that one is not very obvious. Okay, so as I said, take this ans variable here, initialize it to 0, then simply iterate in the nums array, I less than nums dot size and I plus plus, and here then what you have to do is simply calculate ans XOR nums of I, XOR it with the index also, because here we want to cancel out the pairs, and pair we would get using the index and the numbers. Also after this you have to XOR it with n, that is the size, right? Because it is inclusive, right? So ans XOR equal nums dot size, and that is it. After this simply you return the ans, and that is how you're going to get your answer. So let's quickly run it. So it's accepted. So this is basically how you have to do it. Now what is happening here is you are cancelling out all the pairs, and because it is the property of XOR, if you take two same numbers, the XOR would be 0. So you will cancel out all pairs, and the last you will be left with the missing number. So that is it. This is how you have to solve this question.